In section 2 here of the quadratics, I'm going to be showing you how to, number one, graph a quadratic. And what do we get when we graph a quadratic? A parabola. So we're going to be drawing parabolas. Then I'm actually going to show you how you solve a quadratic. Actually, there are several ways you can solve a quadratic. I'm just going to show you today about how to do that by graphing. But let's take care of the graphing first. Well, the first thing you want to do when you graph a parabola is find what's called the axis of symmetry. And we talked about that the other day. What is the axis of symmetry? It's the vertical line that splits the parabola in half. So what's a vertical line? The equation is x equals, some number. Well, how do we find that number? Well, it's a formula we'll always be using. We're always going to use x equals negative b over 2a to find the axis of symmetry. And we were working with that a little bit the other day. So we should not have a problem doing x equals negative b over 2a. Then after you find the axis of symmetry, you're going to find the vertex. And what's the vertex? Well, the vertex is a point, and it's the point being x and y. So we're going to have to find the point x, y here eventually. And it's the point where the parabola actually changes direction. Remember, in a parabola, if you're throwing a ball up in the air, you throw it up in the air and it goes up, 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 and then eventually it turns and comes down. Well, the parabola has a vertex, and that's at the very top of that type of parabola. And that's the vertex, the point where it changes direction. Stops going up, starts coming down. How do we find the vertex? Well, we take that number that we got in step 1, and we're going to plug it into the original equation. That word is equation right there. And that's how we're going to find the vertex. After we find the vertex, we need to make a table of values. And what I'm going to have you do is I'm going to have you plot 5 points. So your table of values is going to contain 5 points. So you need x and y. And the vertex, since it's at the very top or the very bottom, and I have 5 points, I need 4 other points somewhere, right? Well, that vertex is going to be the very middle of your table. And then I'm going to have 2 numbers on this side of x and 2 numbers on this side of x. So basically what I'm going to do here, not every time, but I'm usually going to go x minus 1, x minus 2, x plus 1, x plus 2. And I'll show you what I mean by that in just a few minutes as to exactly how we come up with our numbers for x. After we do that, we can come up with these numbers for y. We'll have our table, and we'll be able to draw the parabola. Here's what I mean. Let's look at problem number 1. We have y is equal to x squared plus 2x minus 3. Now, it's always a good idea to start with what a, b, and c are. A is equal to 1, b is equal to 2, c is equal to negative 3. Well, the axis of symmetry is x equals negative. Now, that negative sign goes in front of the fraction bar, and it'll get confusing if you don't. So we're going to have negative b over 2a. Now, here's that negative sign. What's b? 2 over 2 times what? 1. And x equals negative 1 is the axis of symmetry. That's a vertical line, and it's at negative 1. Draw a dotted line because we don't want it to be a solid line. A solid line means part of the graph, and, well, we don't want to go there. So we just leave it a dotted line. So now I need to find the vertex, and I'm going to start making my table of values. And this negative 1 is going to be my middle point because that's my vertex. And to find out what this y is, I'm going to plug in negative 1 for x here and here, do the math, and we'll figure out what y equals. So y is equal to negative 1 squared, which is positive 1. 2 times negative 1 is negative 2. 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So that is your vertex. Mark it V for your vertex. And that's at negative 1, negative 4. So we put a point here. Now, here's what I mean by, when I did this earlier, I went x minus 1 and x minus 2, x plus 1 and x plus 2. I need 2 more points on this side of that vertical line, and I need 2 points on this side so that I can get a good idea of what the parabola will look like. Well, how am I going to do that? I'm going to pick 2 more x's. I'm going to use -2 and -3, and then 0 and +1. And that'll give me 5 numbers right in a row that I can use for x. Now, -3, let's try it. -3 squared is +9. 2 times -3 is -6. 9 minus 6 is 3. 3 minus 3 is 0. -2 squared is 4, plus 2 times -2 is -4. 4 minus 4 is 0, minus 3 is -3. So I have -3, 0, -2, -3. And because it's symmetrical, axis of symmetry, symmetrical, what happens on one side, and here's what's happening on this side, my parabola is going up like this. Whatever's happening on this side will be reflected on this side, or at least it should. So what does that mean? Well, let's plug in 0 into our equation and see what happens. 0 here, y equals -3. These two numbers should be the same, and they are. When I plug in 1 squared is 1, plus 2 times 1 is 2, 1 plus 2 is 3, and 3 minus 3 is what? 0. So I'm going to go to 0, -3 and put my point. 1, 0, put my point, and look what happens. This is symmetrical in that this side is symmetrical to this side. When we fold this parabola over the axis of symmetry, or if we were to fold that in half, the right side would be matching up with the left side, and that's how we get your symmetry. So when you draw your parabola, always make sure that it's either looking like a string that's drooping, a nice smooth curve, or a ball that's being thrown up in the air if that were the case. All right, number 2. Y is equal to x squared minus 4. A is equal to 1. B is equal to, what do you think? C is equal to -4. So B is equal to 0. So axis of symmetry, x equals -b over 2a. -0 over 2 times 1. 0 over anything is 0. So x equals 0 is the axis of symmetry. Draw a dotted line. Table of values. I need 5 points where 0 is going to be the middle one. 0 is always easy. When you get 0 here, that cancels that out. Y equals -4. Now I'm going to use two numbers smaller than 0. So 0 minus, that's what I was getting at earlier. X minus 1. 0 minus 1 is -1. 0 minus 2, -2. +1 and +2. And that's going to give me my 5 nice round numbers that I'm going to be able to graph this parabola. Well, -2 squared is 4. 4 minus 4 is 0. -1 squared is 1. -4 is -3. 1 squared, 1, minus 4, -3. 2 squared is 4, minus 4 is 0. So I'm going to go to -2, 0, -1, -3, 0, -4, 1, -3, and 2, 0. And again, you're going to draw your drooping string or drooping rope, a cable or whatever, and make sure it's a nice curve here. See, notice that you can never get your parabola to do that, right? It's not going to come down to a V, so you don't want to do that. A nice rounded curve down here at the bottom. Looks like I changed ink color there. You know, doesn't have to be exact. Parabolas are not going to be exact, but we can get it to look pretty close, and that's what that parabola will look like. Now, if you noticed in numbers 1 and 2 here, A was equal to 1, well, A is equal to 1, but they're both positive, right? Which means both of these parabolas do what? Right, they both open upward, right? Well, what's going to happen in number 3? Right, this one's going to be opening down, so make sure we get that at the end when we actually draw the parabola. All right, A is equal to -2, B is equal to 4, C is equal to +2. We want the axis of symmetry. First thing you do after you find the A, B, and C axis of symmetry, you have x equals -b over 2a. Now, here's the negative sign. B is equal to 4 over 2 times -2. That's -4 over -4. X equals 1 is the axis of symmetry. Now what? You make a table of values where 1 is the vertex. You're going to mark that V for vertex. Now, what are the two numbers that you're going to use for x that are less than 1? You're going to use 0 and -1. And then you use the next two numbers that are bigger than x, 2 and 3. Now, I'll tell you what. You go ahead and pause the video. When you come back and restart the video, we'll have numbers 3 and 4 done already. See if you come up with what I come up. So go ahead, pause the video, do numbers 3 and 4. We'll be back in just a minute. All right, so in number 3, if we have the vertex at 1, 1 what? Well, when we plug in 1, we get +4. At 0, we get +2. At -1, we get -4. 2, 2, and 3, -4. So our parabola is going to go like this. It's going to come up, throwing the ball up, curves around, and comes down through that point. So there's your parabola for that one. And as we were saying earlier, this one does open down. Now number 4, okay, the one time that we get a fraction, and it's a nice even fraction here at 1/2. That's your axis of symmetry. So we're going to mark our vertex is 1/2, and when you plug in 1/2 and plug it in for x here and here, you get -2 and 1/4. So at 1/2, -2 and 1/4, we have our vertex. Now, I'm going to go to 0 and -1 and 1 and 2 for my other 4 points for numbers for the domain, numbers that I'm going to plug in for x. And when I do that, I get -1, 0, 0, -2. I have my 1/2, -2 and 1/4, 1, -2, 2, 0, and my parabola will look like this. It comes down, swoops down through this point, comes back up. It's that drooping string that we were talking about, and we get that. So that's how you graph parabolas. All right, so let's talk about solving quadratics. If you are ever asked on any kind of test to solve a quadratic, to find the solutions, if you were to find the zeros, find the roots, find the x-intercepts, these are just different ways to ask for the same thing. To solve a quadratic, all you need to do is tell me where the parabola touches or crosses, if you will, the x-axis. So what would those numbers be? So let's go back to the first page here. In number 1, where does the parabola cross the x-axis? Well, at -3, what's x equal to at this point? -3. And what's x equal to at this point? +1. And those would be the solutions or the x-intercepts, the roots, the zeros, and that's what we're talking about, where it touches the x-axis. How about on number 2? Well, at -2 and +2. Here in number 3, it'd be a little bit difficult to tell because it's between these 2 points here. So we're not going to go into that quite yet. It'll be between these 2 points here. We're not going to go there yet. How about number 4, though? How about at -1, and +2. So we just solved those. So how does that equate to doing what we're doing in this part? It's the exact same thing. We have to graph the parabola and then tell me where it crosses the x-axis. So I'm going to go ahead and get you started with x equals -b over 2a. Remember, a is equal to 1, b is equal to -2, and c is equal to -3. So x equals negative. Now, what's b equal to? -2. So the negative that's part of the formula is this negative right here. What's b equal to? -2. So you have to have both of those negatives in there. Over 2 times 1. I'll get you started there. In number 6, a is equal to 1, c is equal to -1. What's b equal to? Right, b is equal to 0. X equals negative, and then b is equal to 0 over 2 times 1. X equals 0. Now in 7, what's different about this one? Well, we have 6 on the right side of the equation. What have we always had before? Well, we need 0. So to get 0 here, we're going to subtract 6 from both sides. And we get x squared minus 2x minus 6 is equal to 0. And now we can say that a is equal to 1, b is equal to -2, c is equal to -6. Go ahead and graph these. Stop the video if you want, or wait until the end, whatever. But I would encourage you to stop the video right now. Go ahead and graph these and see what you come up with. I'll be back in just a few minutes. All right, let's take a time out here and show you something about parabolas. Let's say I'm up here on this ladder, right? Not a very good likeness of me, but we'll have to do with that. And let's say you were down here. Again, not very good, but we'll have to deal with it. Now, I need a roll of tape from you. Now, I don't want to climb down the ladder and so on, so you're going to toss it up to me. Now, if you were to toss it up to me way up over my head and then back like this, how many opportunities do I have to grab the tape? 1, 2. That means there are 2 solutions there. Okay? Or maybe you just toss it up high enough that I could grab it right there before it falls, right? How many times can I grab the tape? Just once. So I may only have 1 solution. Or you may really mess up and not even get it up there at all, right? And it falls back to the ground. How many times can I catch the tape? None, right? So when we're talking about solving a quadratic, we're talking about the parabola being able to touch the x-axis twice. Who knows? Maybe it's only going to touch it once, or maybe it doesn't touch it at all. So in this case, the first case, we're looking for 2 solutions. In the second case, we're only looking for 1 solution. And in the third case, where it doesn't touch the x-axis at all, there would be no solution. So now let's go back and talk about solving these parabolas, these quadratics. The first parabola, number 5, touches twice at -1 and +3. The second parabola touches the x-axis twice at -1 and +1. Let's look at number 7, though. And there's all the work for 7. Give you a second there to copy that down if you need to. But how many times does it touch the x-axis here? Don't say it doesn't. Do not say it's no solution, because actually these curves continue on forever in this direction. So actually it does touch the x-axis. We just didn't originally draw our parabola tall enough to do that. But it will touch, in this case, the x-axis twice. Now, here's the deal on this one. Let me blow this up a little bit for you here. Now, there is no way I'm going to be able to guess as to what that point is. I know it's somewhere, though, what? Between -1 and -2. But I could take forever to find out exactly what point it is by substituting maybe 1.5 into that equation. Or I could take, -1.7 or -1.75 or somewhere. It would take me literally, could possibly take me literally forever to find out what point would actually make that true. So we're not going to do that. We're just going to say that this point is somewhere between -1 and -2. How do we write that? Well, we're talking about x, right? And we know it has to be less than -1. But at the same time, x has to be greater than -2. So that's how we would write that one. This one is going to be between, well, here's 0, 1, 2, and 3, is somewhere between 3 and 4. So I know x is going to have to be less than 4, but at the same time it has to be greater than 3. And that's how we will show this solution for this one. Now, fortunately, that won't be a question like this won't be on the test, but who knows? It may crop up in some future algebra course or maybe on some standardized tests like the ECA, the PSATs, or the SATs. So get yourself familiar with how this is written and how I've written these inequalities. Let's move on to the story problem. Now, just because it's a story problem, don't freak out and think you can't do it. Let's read the problem and see what it says. Steve jumps off of a diving board. His height, h, now, and that height will be feet. His height at any given time is, and that'll be seconds, is given by the equation, or the function, y is equal to -2x squared plus 4x plus 15. So we're going to make a table of values to show his height at 0, 1, 2, 3, and 4 seconds. Well, we can do that. We know how to do that, right? Just make a table. Now, instead of x, though, we're going to use t, and instead of y, we're going to use what? H, right? Because that should have been written h equals -2t squared plus 4t plus 15. All right, only a slight error there. So if you would, fix yours so that it reads h is equal to -2t squared plus 4t plus 15. If it's not already. You may already have that, you may not, depends on which form you got. So if you have h equals -2t squared plus 4t plus 15, know that that is the function that we're going to use to find the height after so many seconds have gone by. And so now what we're going to do is make a table of values where t is the x and h is the y. Think about this. We had earlier y is equal to -2x squared. Well, here we're going to have h is equal to -2t squared. So the t is the x, the h is the y, and we're going to go from there. And we're going to plug in values for 0, 1, 2, 3, and 4. So after 0 seconds, this means when we say the height, we're talking about how high off the water. How high above the water is he? Now, being in 0 seconds, what does that mean? Well, it means he's still on the diving board, right? He hasn't left yet. It's the moment right before he leaves the diving board. So he gets up there, he springs off, and he's going to fall into the water, right? Hopefully, if he hits the pool anyway. So we're going to plug in 0 in for t here and t here, and we get what? 15 feet. So that means the diving board is actually 15 feet off the water. Now, so he springs off the diving board, and 1 second later, where is he going to be? Well, we're going to plug in 1 here, and we get 1 squared is 1. That would be negative 2. Negative 2 plus 4 times 1, that would be 2, plus 15 is 17. So a full second later, he's at 17 feet. Because he's springing up off the board, right? And let's try see what happens when t is equal to 2. Well, 2 squared is 4. 4 times negative 2 is negative 8. Plus, and then 4 times 2 is positive 8. So that'll be negative 8 plus 8 is 0. Plus, so he's at 15 feet again. So 2 seconds later, he goes off the diving board, and 1 second later, he's 17 feet above the water. 2 seconds later, he's 15 feet above the water. All right, maybe that works, maybe that doesn't. But all right, we're going to run with it anyway. At 3 seconds, that'll be 9, negative 18. 4 times 3 is 12. Negative 18 plus 12 is what? Negative 6 plus 15 is 9. So it's then at 9 feet off the water. And then we're going to try 4. So t squared, 4 squared is 16 times negative 2 is negative 32. And 4 times 4 is 16. So negative 32 plus 16 is what? Well, negative 16, right? Negative 16 plus 15 is what? Negative 1. Well, what is that? What? Does that make sense that he's negative 1 feet above the water? Yeah, it means he's hit the water. He hit the water sometime between 3 seconds and 4 seconds. Well, how are we going to graph this? Now we have to graph these values, right? Well, on the x-axis or the t-axis, we're going to put the number of seconds. So I have 0, 1, 2, 3, 4, 5, 6, and 7, and so on. So, okay. And then I need to show 17 on my y-axis. This 1, 2, 3, 4, 5, 6, 7, 8, 9, that only goes up to 10, right? So what if I doubled these? What if I went 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20 feet? So at 0, I'm at 15 feet, which would be right here. 1 second later, I'm at 17 feet right here. 2 seconds later, I'm back down at 15 feet again. That's your parabola, right? We get the maximum height at 17 feet. 3 feet would be 9, so we're going to go here. And at 4 feet, or 4 seconds, we're at negative 1 feet, somewhere down here. So it's going to look something like this. And he hits the water right there. Okay, so that's how we would take care of that one. All right, good luck on your homework, and we'll talk to you next time.